All right, got cut short, so here comes part two. And here we go. So we were trying to do the estimate and interpret the p-value. So estimate would have been 0%. So estimate would have been 0% because there were 0 dots over there. Interpret is going to be this, starting with assuming the true mean, there is a 0% chance of getting a mean difference, because that is our test statistic now, of 32.7 or more by random chance. Okay, so there's your interpret it. So based on the p-value, make an appropriate conclusion. So here's where you start with since. So since p was definitely very small, so p was definitely less than our significance level. Okay, that means, of course, random chance is not a plausible explanation here. Okay, meaning you definitely reject the null. Okay, so therefore we have evidence. The Rockies had a greater, had a higher, had a greater. Just gonna throw it all in here. Greater true mean, which means they had a greater ability to hit home runs at home. Okay. So if there is convincing evidence that the Rockies had a greater ability to hit home runs at home, can we say that the thin air is the cause? And again, this is the word that you always want to be careful with. We're not here for that just yet. So, alas, we cannot show cause. Okay? There could be a strong correlation, or we just know there's a great ability now. We have evidence of that, but we cannot show cause just yet. If you're going back, I think the term was confounded, meaning there are other variables at work as well. All right, so now moving on to the next screen. All right, so example, can students throw a baseball farther than a softball? So determine whether students can do this, whether they can throw a baseball farther than a softball. Statistics class went out to the football field at their stadium, conducted the experiment. After warming up, each student threw a baseball as far as they could, and the distances were recorded for each throw. So how many students we got? Looks like we had 24 students. And we got each measurement, baseball, softball. And hey, the good thing is they found all the differences for us. So what we're going to do is calculate the test statistics. So again, we're looking for the mean difference. Yeah, squished right there. So again, we are looking for the mean difference. And I had to take like a small departure just to make sure I got my numbers together. And let me make this neater while we're here because that's going to bother me. So test statistic again, this is your mean difference. So I added all those numbers up, all my differences, and I got, let's see here, 157. And then I'm going to take the average of that. So I divided by how many students I got, which was 24. And that got me 6.54. This represents my test statistic. This is the mean difference. So that is the mean. That's the average of all my differences. Okay, once I put them in the calculator. So interpret the test statistic. Um, that means that if we average out all the distances, I'll say that, the average or the mean of all 24 differences is 6.54. Okay, write your hypotheses. All right, let me give a little more room. So, null. Null is always going to be about having the same ability or the same true mean. Okay, in this case, it'd be the same ability to throw a baseball or softball. Let's do that. And then for the ha, we would say something about a greater ability or greater true mean here. And in this case, greater ability to throw baseball. Okay, more so than softball. All right, last screen. So here are the results of 100 trial simulations. Describe what information provided by the dot plot. So again, this is 100 simulations where, or 100 simulations of 24 students where you get a mean difference of 6.54. So 100 simulations of 24 students where mean difference is 6.54. Okay, so use the results to simulate and estimate. Wait, use results of the simulation, estimate, and interpret the p-value. So 6.54. Again, here we go. Way over here somewhere. I'm just going to label it right there. And if you count dots, it's going to be easy. There's 0 dots this way. So when we estimate the p-value, we're going to have basically 0%. And when we interpret it, we're going to say, assuming the true mean, same true mean, assuming the null, there is a 0% chance of getting a mean difference of 6.54 or more by random chance. Okay, so based on your p-value, make an appropriate conclusion. So since p was small, less than 0.05, therefore random chance is definitely not a plausible explanation. Not the plausible explanation. Okay, which means basically you are rejecting the null. Okay. Therefore, there is a greater ability. There is a higher true mean. For the baseball. In other words, there is a greater ability to throw the baseball. Okay. And that concludes it. That is part 2. So hope you're doing well. Hope all's well at home. Hopefully 2021 is going to be a little bit better in 2020. All right, y'all have a good one.